Hello and welcome to my channel. Today I'm going to do a deep dive into a high-end, do-it-yourself build, of an e-drum kit, sound isolation platform. This build utilizes a highly effective vibration dampening product called Sylomer, SR11. More on this, after this brief message. If after this video, you have found it educational or useful, please don't forget to hit the like button and subscribe. I love to hear your comments, so do let me know what you've thought in the comments section below. For notifications of future videos, including song covers and other cool builds, choose all notifications, in the notification drop-down bar, so you don't miss anything good. Even though electronic drums are designed to be quiet, there is still the noise produced from physically striking the cymbals, toms and kick pad, with drumsticks and kick hammer. "100 Hz seems to be the culprit and originates from the kick pad. This vibration is transmitted from the strike zone, through the frame, and then into the floor. Toms can't really be heard outside a closed room, if you're using mesh pads. Cymbals can travel into adjacent rooms to a degree, if you hit them hard, but won't really penetrate into the floor. Both the cymbal and the tom strike sounds can be further reduced by using silicone tip covers on your drumsticks. They add a little weight, but they do actually work. These sounds, especially if you like to utilize a double kick pedal, can drive a perfectly sane roommate or downstairs neighbor bonkers in a hurry. Measure out the area where you and your electronic drum kit sits, making sure to give enough space for everything to sit entirely on the platform. Allow at least 2 to 4 inches of extra room all around. Nothing should be in danger of slipping off. 3/4 inch thick, 49 by 96 inch, medium density fiberboard sheets, are huge and heavy. For this reason I chose to make the platform break apart into 2 pieces and will bolt together underneath. I was lucky enough to only need 49 inches of total width and 70 inches of total length. This join at 2 feet, would allow me to get it upstairs and around corners, and to move it by myself if necessary. My first consideration was the quality of build I was willing to pay for, versus the finished unit's effectiveness. The deciding factor was pretty simple. I could build something cheaply using cut-in-half tennis balls, then suffer from the ocean waves that rock the throne as I play. Or worse yet, not work at all, or build a quality unit that would be heavy enough to create a stable platform before I even get on it. And use a product designed to dampen vibration. I decided to go with the quality option. Carefully considering the materials I would need, I decided to use Medite, or medium density fiberboard, also known as MDF. This product is heavy and easy to work with, and because it is manufactured, it is perfectly straight. I chose to laminate 2 3/4 inch thick MDF panels together with wood glue. This would make a deck thickness of 1.5 inches, which would be both durable, but more importantly, heavy. Cut your panels to size, as per your measurements, and make the center cut where they will later bolt together. You should now have 4 identical panels, ready to glue. It is a good idea to get your wood retailer to make the center cuts for you. And be sure to tell them to cut everything on the line. Spread the wood glue across one surface quickly but not too heavy, paying extra attention to the edges. Lay the panels together and set heavy objects on top. I use 4 18-kilogram boxes of kitty litter, and 4 car tires on rims. Make sure to watch the top board for drift on the wet glue for a while. Eventually the excess glue will squeeze out and soak in a bit and the board will stop moving. Leave to dry for 18 to 24 hours in a warm, dry environment. Once dry, make any specialty cuts as needed. For example, I needed to cut an 8.5 inch by 8 inch square out of the left front corner, so at least one of my closet doors would open. Also clearly mark the top, bottom, front and rear, as this will make things less confusing during construction. 2 12-inch wide by 35-inch long 3/4-inch thick MDF boards were utilized as bolt plates to join the two slabs together on the bottom of the deck. Using a tape measure, straight edge and a fine-tipped felt pen, measure your center and mark it with a straight line. Be sure to label each bolt plate and deck slab so you will know where on the deck bottom each plate goes, and its orientation. This is important. Create a grid of measured intervals on the bolt plates, making sure at least 1 inch of distance is left from the center line and from the edges. The intersections and lines must be evenly divisible across both plates. The main thing is that the bolt pattern needs to take up the pressure evenly along the bolt plate. Therefore, you won't need to put a bolt at every intersection. I had originally planned for the pattern as follows: 4, 2, then offset 3, 3, 3, 3, 3, 3, 3, 3, 3, then center 2 and starting 3 and oppositely repeating across the other bolt plate. I ended up with the following: 3 then offset 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, then repeated oppositely across the other bolt plate as indicated in the video. Before you drill, use pieces of green painter's tape on the line intersections, until you have a bolt pattern that is evenly distributed. Don't be afraid to play around with it for a while to get the best pattern. A hidden capture fastener is commonly known as a T-nut, and are utilized in order to keep the deck's top surface flat. We can't have our bolt ends sticking up from under the carpet making obscene bulges all over now. Drill the bolt plate holes first, with a 1/8 of an inch or smaller drill bit, to create a pilot hole, then use the bit that corresponds to the size of the bolt you have chosen to use. Do not drill the platform slabs yet. If you drill a hole bigger than the guide spine on your spade bit, when you go to countersink the T-nuts, the spade bit will not drill evenly and consequently, flop around horribly as it cuts into the wood. Place the two halves of the platform on level sawhorses or on a level floor. At the length ends, where the two slabs come together, make sure they are tight, even and the two surfaces are flush with each other. Drill a pilot hole at a 33 or 45 degree angle from one slab edge into the other slab, so the two halves can be tacked together with long skinny screws. This is temporary and one screw per end should be sufficient. Once this is achieved and you have verified everything is even and flush, clamp, or temporarily screw down the two drilled out bolt plates onto the now semi-joined platform. If you opt to use screws, make sure they do not go in more than half of the platform slab's thickness. Trace a line along the bolt plate edges onto the platform bottom, to indicate where the bolt plates sit once removed. This will become important later in the build. Using a skinny pencil or some other marking utensil, mark for the bolt holes on the platform deck bottom, through the bolt plate holes, making sure you mark in the very center, or can shade in the hole completely. Remember, the bolt plates go on the bottom, and the two slab halves must be tight together, flush and even. Once marked, remove the tack screws and bolt plates. Drill small pilot holes at your marks, through the laminated deck boards. Remember, try your hardest to keep the drill square and perpendicular, or your holes may wander slightly and not line up properly later on. Do not drill out these pilot holes with your chosen bolt size yet. Turn the slab boards around, so that up is facing up. Use an appropriately sized spade bit to countersink the T-nuts into the deck face, where your pilot holes have exited. Be careful to only sink them until they are flush or a fraction better. Finish the countersinking by sanding away any loose pieces formed during drilling. Now we can drill out the pilot holes with your chosen bolt-sized drill bit. Make sure you drill them out from the top, where you just countersunk the T-nuts through to the bottom. This is important. And remember, to drill straight is truly great. Never hammer T-nuts into place. They may break, or more importantly may not set properly compared to the bolt's position through the wood. Remember, we are using a hand drill. A drill press would solve this problem, however if you're careful, it shouldn't be a huge issue. The best way to set T-nuts is by drawing them in with a bolt and washer, as this ensures proper alignment. Do not include the lock washer in this step. Once all of the T-nuts have been set, the moment of truth has arrived and it's time to see how well you measured everything. Bolt down the bolt plates and tighten, but not overly tight. You may need to pull a few holes in the bolt plate a little one way or another with the drill, in order for the bolt to go into the deck holes. Do not hammer the bolts in, as you may push out the now set T-nut, which will be very inconvenient. Check to make sure your bolts aren't too long. We don't want them to stick through once the carpet is on. If all is good, leave together for an hour to set, then disassemble. That's right kids, it's carpet time. For this application, a short pile with a full loop is the best choice for resilience, crush resistance and ease of cleaning. Known as Berber, or more commonly called commercial carpet, this type of carpet typically lasts about 7 or 8 years. As for manufacturing processes, woven carpet lasts the longest, but is the most expensive. Way expensive. But hey, whatever you like. Tied carpet is next in line, like Axminster for example, but is still pretty pricey by the square foot. It is also difficult to find in Canada. Most of the readily available carpet today is produced by tufting. Tufting is a process where thousands of needles loaded with yarn push the yarn through a primary tufting substrate to make the carpet's surface. This, in turn, is joined with adhesive to other layers, and then a final layer of woven polypropylene mesh serves as backing. I ended up going with a short pile, full loop, tufted carpet, and although I did not find the color I wanted, what I did get was a decent price, and looked pretty good in the end. Measure the 2 platform slabs and allow 3 to 6 inches, or whatever you need, of extra carpet everywhere except where the 2 slabs come together in the middle. This excess carpet will be for the sides. Where the 2 slabs come together in the middle, still allow an inch or a little less, so you can make sure the glue sets all the way along the edge. This will eventually be cut flat. So go ahead and cut the carpet into the 2 pieces that you need and label them, piece A and piece B. At the same time, label the respective slabs with carpet piece A and B. Place the slabs on your upside down carpet pieces top side down and position it, like shown in the video. With your felt pen, outline the slab on the carpet backing, so you know where the edges of the slab are, when applying the adhesive. Stand the slab on its side, in preparation for laying onto the adhesive, once it has been applied. I used Roberts 3085 multi-purpose adhesive, which is available at Amazon. This adhesive dries in 12 hours and takes 3 to 4 days to fully cure. Following the slab's outline on the carpet backing, spread the carpet adhesive so that it goes to the outside of the felt pen line. Do this all around the slab's outline and make the glue line at least 2 or 3 inches wide. Make sure the carpet's woven mesh backing is filled with adhesive and that there is enough to ensure full wood-to-glue contact. You don't have to spread the glue overly thin, but if you use too much around the edges, it may make a mess when weight is applied, and take longer to cure. When applying the adhesive, spread it all from the top to the bottom, so you don't have to work over top of previously applied glue lines. Adhesive must be fully cured before cutting with an X-Acto knife blade, otherwise the partially cured glue will gum up the blade horribly, and hinder the ability to achieve nice straight cuts. With a couple more 3 or 4 inch wide strips of adhesive spread down the middle, lay some cross strips that will intersect them from side to side. You can proceed to carefully lay the slab into place. 2 people would be handy for this step, however, if you're careful, it should drop in pretty close to its mark. immediately make sure that the slab fits within the felt pen outline and adjust it if necessary. Take a small spreading tool, like an old knife, and use it to lay down a line of adhesive, where the carpet and slab's edges come together. This will ensure full adhesion. Place a bunch of weight on top and leave for a minimum of 12 hours. After the glue has dried, we can start fabricating the slats. These will act as the feet that will hold the deck up off of the floor. Since the Sylomer kit comes with 4x4 inch squares as the largest piece, I thought it prudent to make my slats 8 inches by 8 inches, so that it would be able to accommodate 2 pieces if necessary. One slat was made at 6 by 18.5 inches, which just kind of happened. Begin manufacturing the slats by using 3/4 inch MDF and cutting enough 8 by 8 inch squares to evenly distribute the platform's weight. These are the primary slats and will mainly hold the Sylomer needed to elevate the raw platform weight before zone weights are added. This will be covered further in another step. Slats should be placed at each right angle and 2 in the middle on each slab, as well as 2 more close to the bolt plate on the front and rear, as shown in the video. You will now begin to see why we marked where the bolt plates sit with a felt pen. Be sure not to go too close to the bolt plate with a slat, or the bolt plate may not fit in properly. Now that we have the 3/4 inch slats cut, we will need to also cut the same size and amount of 1/2 inch MDF slats. The reason for this is because the bolt plate is 3/4 of an inch thick and the bolt heads stick out by a little under 1/4 of an inch. The 1/2 inch slats are therefore required to get the bolt plate up and off of the floor. Keep in mind that the Sylomer is 1 inch thick and probably around 1/2 an inch or more when compressed, so there will be plenty of floor clearance in the end. Now we will need 3 different lengths of wood screws for attaching the slats to the slabs. 1.5 inch for the bottom slat, and 2 inch for the top, and 1 inch for the slats that will attach to the bolt plates. This ensures the screws all make it into the main platform. Remember to always drill pilot holes for every screw and be sure to set your drill bit depths. Pilot holes should be the size of the screw shaft or preferably slightly smaller. Length of drill bit must be adjusted for each length of screw. Length should be as long as the screw's shaft, minus a millimeter or so. Screws should never penetrate into the top 3/4 inch piece of MDF. Pilot holes should be countersunk slightly, by hand turning the guide spine of your spade bit around in the hole's entrance. You want the screw head to be flat with the slat surface once tightened. Lay your slats out across the bottom of the platform slabs, as per your diagram. Keep in mind where the bolt plates sit on the slabs. Keep slat squares about 1/8 of an inch away from the bolt plates' felt pen lines. Once the first set of slats are strategically placed, outline them with felt pen. Hold one down firmly in place and drill pilot holes in 2 opposite corners, about an inch or 2 in from the slat's edge. Do not allow the slat to move between drilling the holes. If it does, countersink the pilot hole as mentioned before, and attach the slat with the smaller 1.5 inch screw. Reorientate the slat, then drill the second pilot hole. Once both holes are drilled and countersunk, leave the screws in the slat until just the tip sticks out. Proceed to spread wood glue across the entire surface of the slat bottom. Keep track of the slat's orientation, as not everything will be perfectly square, including the screw hole placement. To remedy this, place an arrow on the platform slab, with an ink pen, and one on the slat, before applying the glue. Place the arrows so they come together when the slat is properly aligned. Proceed to screw down the slat until the screw head sinks level with the slat surface, or a bit better. You should almost hear the screw make a tick sound towards the end. Glue should be oozing out at this point, so use your finger to press it into the crack along the attachment seam. The rest can just be wiped away with an old rag. Now take a 1/2 inch slat and position it so it sits on the previously attached one. Turn it around a bit to find the best possible fit. Place an X mark in each corner, where the screws are at in the first slat, so we don't attempt to screw a screw into a screw. Besides, this really wreaks havoc on your small drill bit, when you attempt to drill the pilot holes. Replace the slat into its best position and drill 2 more pilot holes in the opposing corners, as compared to the first slat. Do not glue this one down. And don't forget to use alignment arrows and the 2-inch screws. Attach all your slats as previously prescribed, keeping in mind that we are not done cutting slats quite yet, and we'll come back to that in a following step. The idea is that, if I need to move the platform someday, the Sylomer is very likely to get damaged. Because honestly, the slabs are heavy and awkward. This way I can unscrew the top slat with the attached Sylomer foam, and mark them so they all go back in the same positions, then pack them away safely. We may now continue, by attaching the carpet to the edges of the deck. This step will require a heavy-duty stapler and sufficiently long staples. The gun must be able to sink the staple in completely tight, without having to hammer them in. Princess Auto has one for $9 Canadian, that worked exceptionally well. Sitting on the deck wood, opposite to the carpet you're working on, pull it hard, working it against the 90-degree edge. This will break its stiffness and make it easier to get a tight seam. Do this all the way along, trying to keep it tight at the 90-degree bend. When you think you have it ready, use a felt pen to mark the carpet backing, level along the bottom of the slab, using it as your straight edge. Start from the middle and work your way out, 25% at a time, on each side respectively. This will ensure that your felt pen line will be straight across the carpet's entire length. Remember to keep the flattening hand a few inches ahead of the pen, to ensure the carpet is square with the slab's edge. When you come to the slats, mark only up to where the glued down first slat ends. From the other side, do the same thing, completing the line with a straight edge. Continue this algorithm along all 3 sides, on both slabs. Outer 90-degree corners can simply be cut in the same direction the slab edge that it is attaching to is traveling, as shown in the video. Leave the 2 sides that bolt together for now. You want a good hard cure before cutting. With a 1/2-inch thick board under the carpet to protect the floor, use your sharp blade to cut along all of your felt pen lines. Try to keep your cuts in the middle of the lines. If you've had to cut out a chunk like I did, it then becomes an inside 90-degree angle and cutting, marking, gets a bit more interesting. Look closely at the picture on pause and you won't have any issues. Exposed wood can always be blacked out with felt pen. Once you have cut all of your lines, it's time to permanently attach the carpet to the edges. Using an appropriate utensil, spread the adhesive on both the carpet and the wood surfaces, making sure to only cover the first of the 2 slats, so the second slat can still be removed. Starting from the middle, push the carpet up and into place firmly. When it looks smashing, sink in the first staple. Once you have an anchored midpoint, work one side and then the other, just like when marking the lines. Make sure to keep it tight against the angle as you firmly attach it. Continue doing this to all of the wraparound carpet, except the sides that bolt together. Whilst patiently waiting the 3 or 4 days for the adhesive to fully cure, it's a fantastic time to prepare for the Sylomer and to fabricate the secondary slats. These slats will provide additional real estate, in order to accommodate more Sylomer blocks. These will be strategically placed to counter zone weight. Zone weight is the total combined weights of the items that sit in a specific area on the platform, including you. Break the platform into 4 hypothetical zones, starting with where you sit and moving forward, right and then back. This may vary if you're left-handed. You will now need a handheld luggage scale, that can weigh 100 pounds or more. Mine will scale up to 110 pounds, and has a continuous read feature that reads more accurately than when in pause mode. It is also available at Amazon. You must weigh everything while taking note from which zone it came from. When finished weighing an item, remove it from the area. This includes frame pieces, cymbals, kick pedals, stands, etc. everything. You will also need your present body weight. Once you have everything weighed, you now have the total secondary zone weight totals. Using actual size pieces of paper, mimic the Sylomer foam pieces, in the kit you're buying, so you can figure out how many secondary slats you will need. These slats will accommodate the additional pieces of Sylomer, needed to offset the various zone weights across your platform. The most pieces added, will likely be under where you sit. For example, I am a 250 pounder, so that, in itself, is 10 4x4 inch blocks, under my throne zone alone. This means that I will need a minimum of 5 additional 8x8 inch slats, strategically placed in this area. If you notice in my zone area drawing, my sitting zone weight goes out and onto the middle of the deck, where the two halves attach. To evenly distribute the weight of these zones, slats will be needed on the bolt plate itself as indicated in the video. Once you have figured out how many more secondary slats you will need in total, and where they are going as per your zones and zone weights, fabricate them. Keep in mind that any slats needed on the bolt plate will be the 1/2 inch thick MDF, as the bolt plate is already 3/4 of an inch thick, and you can still use the primary slats for zone weight Sylomer as well as secondaries. The slats that need to go onto the bolt plate, must have the bolt head areas drilled out with a spade bit, so it can sit flush on the bolt plate, and provide access to the bolt heads. Glue these slats down using 1-inch screws, each in one of the 4 corners, and make sure to drill pilot holes and wipe away any excess glue that coalesces inside where the bolt will go. Screws must not penetrate through the bolt plate. If they do penetrate slightly, remove them after the glue fully cures. Getting back now to the last step required, to complete this physical build. Place one of the slabs, bottom up on sawhorses and proceed to use a utility knife, to cut away the excess along the 2 slabs' edges that will join together. Use a sawing motion, so the cutting stroke is against the carpet and down the wood edge. We don't want to put any direct, upward pressure where the carpet has been recently glued. Use the flat edge surface as a guide, like a pair of scissors. Be super careful not to cut away any of the wood by accident. This edge needs to be as flat and square as possible. Continue by doing the same to all the overhanging carpet on both slabs. For the finishing touch, use a pair of shears to cut off any hangout pieces of carpet left by the cutting. When finished, your unit should look similar to that shown in the video. Congratulations, you have completed the physical unit's build. We're almost there. Now that you have the 2 slabs fully completed, weigh them with the hand scale. Use a bolt and washer to tie a rope around and screw it into the top corner of the slab. Tie a loop in the other end, so it can hang from the scale's clasp. You will need to stand in a well-elevated position in order to allow each slab to swing freely, as you hold it up. I used a multi-purpose ladder for this step, and it worked out fabulously. Make sure to take several readings to be sure of accuracy. Also put the scale in continuous mode, if possible, as this is more accurate but harder to hold because the slabs are pretty heavy. When in the weighing process, you must apply the lifting force slowly and steadily, until the slab finally lifts off. Excess lifting power in pause mode will especially affect measurements, as the spike of excess lifting power will be recorded as more weight. Expect the slabs to pivot once they leave the ground, and take steps to mitigate this movement, as it will affect your measurements. The time has come to talk about Sylomer, anti-vibration foam. Sylomer is a special elastomer material developed by Getzner, which I believe is in Austria, and is one of the leading products on the international market, for vibration isolation and mitigation. This elastic polyurethane material deforms under tension and compression loads, but always returns to its original form. In doing so, these multi-cell structured materials isolate and reduce vibrations which can have negative effects on humans and the environment. In order to work properly, Sylomer must be loaded to within 80 to 90% of its maximum rated load handling capability, or it will not function as it should. This is easily figured out by finding 10 and 20% respectively of your total in question and adding it to that same total to get your 80 to 90% Sylomer need range. Remember, the bricks have a max load rating. For example, let's say that your total raw platform weight is 100 pounds. 10% of 100 is 10, so you will need 110 pounds worth of Sylomer to put its max rated load to within 90%. In this case, 4 4-inch by 4-inch squares rated at 25 pounds max each, and 2 2-inch by 1.5-inch pieces rated at 5 pounds max each. 20% of 100 is 20, added to 100, is 120. This gives the amount of Sylomer needed, 120, to make the 100 pounds of load reflect 80% of the Sylomer's maximum rated load. In short, your 80 to 90% range in this case is 110 to 120 pounds worth of Sylomer as per its max rating. I chose to go with 16% of maximum, on all totals rounded up. This is a happy medium and will give me some weight leeway, in case I want to add more equipment or if I eat too many cookies. I also ended up with 8 2-inch by 1.5-inch pieces left over, so I do have some extra pieces if needed. I bought the kit from Sundown Incorporated, which consisted of 16 4x4-inch bricks and 24 2x1.5-inch pieces, as well as the extra weight package, which consisted of another 100 pounds worth of 4-inch by 4-inch pieces. These kits are actually made for this purpose, and I have included a close-up picture of Sundown's contact information in the video, for your convenience. Thank you to both Matthew and Leanne, you were very helpful and courteous. Leanne answered a ton of questions and was wonderfully supportive when I didn't fully understand in the beginning. While you wait for your Sylomer to arrive in the mail, it's time to play with our real-size mock Sylomer paper squares. If you haven't done so, mark the 4x4-inch pieces with their respective dimensions and max weight rating. In this case, 25 pounds max. Mark also the 2-inch by 1.5-inch pieces similarly, but only 5 pounds max. If you have to cut some of the 4-inch by 4-inch pieces in half, cut the same amount of mock paper ones and mark them 2-inch by 4-inch at 12.5 pounds max. Your mock Sylomer bricks should directly reflect the actual product that you will receive. Now we will need all our weight totals. For this build, my total raw assembled platform weight is 142.58 pounds, and I decided to put the Sylomer load at 84% of its maximum, so therefore 16% of 142.58 equals 22.81. So then, 142.58 plus 22.81 equals 165.3. This is the amount of Sylomer needed to put its load percent at 84. 84% plus 16% is 100%. I had reasoned that the closer the Sylomer load is to 90%, the more stable the platform would likely be. Now begin to place the 165 pounds worth of Sylomer mock bricks evenly along the primary slats. You will notice that where my closet cutout is, I had to cut a 4x4-inch piece in two. There are a couple other areas I needed these halved as well. Try to spread them out evenly along at least 6 slats, in my case 7 because of the closet cutout. The mock bricks used for primary platform weight should be placed in the middle of the outmost slats, about 1/4 of an inch in from the outer edges. Time now to place the final mock Sylomer squares. First, however, We will need our zone weight totals. Remember, leave as much assembled during the weighing process as possible. Examining my zone view bottom-up drawing, you will see that my zones are D, which is where I sit and the throne. A, which has the snare, extra crash, stands, hi-hat, left side of the drum frame, brain and left double kick pedal. B, which has 2 crashes, 2 toms, the center of the drum frame, the Alesis drum amp, a flat screen TV and the stool they sit on, as well as the right side of the kick pedal and the kick pad. C, which is 1 cymbal, 1 tom and the right side of the drum frame. Zone totals are as follows. Zone A has a total of 36.32 pounds. 16% of this is 5.76. Add 36.32 to get 42.08, but we will round this up to 45. Zone B has a total of 84.24 pounds. Multiply by 0.16, to get 13.47. Add this to 84.24, gives you 97.71, round this up to 100. Zone C has a total of 13.14 pounds. Multiply by 0.16, gives 2.1, which when added to 13.14, gives you 15.24, round this one down to 15. Zone D has a total of 251.3 pounds. Multiply by 0.16 gives 40.2, add this to 251.3 and you get 291.5, round up to 295. Using this information, place the appropriate amount of mock Sylomer squares evenly over the slats that corresponds to the zone area you're working on. If you need to use primary slats now, keep the mock squares to the inside of the slat, as shown in the video. The main thing is to spread the weight for each zone as evenly as possible, without wandering into other zones. Once you have all the required mock Sylomer squares in place, and you feel good about your placement strategy, mark just the edges of the corners up to the tips like placeholders with an ink pen. Marking these on the slat will show that brick's placement, in preparation for the real McCoy. Write the size of the square and weight handling on the slat where the paper was, as shown in the video. This will allow quick placement when the actual Sylomer arrives. Once your Sylomer arrives, jump around and clasp your hands together with excited expressions, for the final steps are in sight. If your room's rug is really shaggy or, if you just want an extra layer of protection, purchase enough carpet to lay down a platform-sized layer for the deck to sit on. Remove your drum kit and prep the area. Lay the carpet in place and bolt your slabs together. Tighten all bolts but not really tight. The lock washer should compress to flat. Now, like a tire, tighten the bolts in a staggered way, working from the inside middle out across both plates, then leave for 20 minutes. Stagger tighten them again, however, don't tighten to the point that the plate gets damaged. If you hear any crunching sounds, it's probably tight enough. You can also keep an eye on how much the washer is sinking into the bolt plate board. Stand up the assembled deck on its side, so it can be easily lowered into place by yourself. Sylomer with P.S.A. peel and stick adhesive, has a wicked adhesive backing. Once the film is peeled off and it's stuck in place, it won't come off without damaging the foam. This can be a problem if you make a placement error. Test the placement by using green painter's tape. Make 1 inch to 1.5 inch tape loops, and fix the blocks in place by the foam face, as tape will not stick to the blue adhesive backing film. Use 4 tape loops on the 4x4 inch bricks, and 2 loops for the 2x4 inch pieces, and 1 loop for the small 2x1.5 inch pieces. Place the appropriate Sylomer blocks on all of the slat areas we marked placeholders out with the mock paper squares. Gently set the deck into place. If adjustment is required, only move each side by a fraction of an inch, or less, at a time. Finish settling it by lifting the opposite side from the last one you moved, off of the floor straight up, then straight down. This will take any twist pressure off of the Sylomer blocks. Set up your drum kit, and replace any other items you included in your zone weight totals. Once complete, pull up a throne and play around for a bit. I chose a heavy bass platform on purpose as figured it would just increase overall stability. Things do move around a bit, but compared to other builds I've seen in online videos, this is like driving in a Cadillac. No complaints. Once satisfied with the stability, rip everything off of the platform again. Raise the deck back up, so you have access to the foam blocks again. Remove the Sylomer blocks, and then the tape that was holding them to the slat, one at a time. Peel the blue backing film off of the adhesive, and carefully set the blocks into the placeholder marks, and press down on them firmly, to set them well onto the slat. Replace the now finished platform, back into its place again. Be super careful while positioning it, then set up your instrument and you are ready for a smashing good time. I will now share the results of my own sound test, as well as others I have found on the internet. I did 2 sound samples with the same device, one before and one after. I am using my double kick pedals with the same force in both takes. Turn your volume up before the first sample starts so the thumping is clear, then leave it at that volume and compare the 2 clips' sound levels. I figure there is approximately a 40 to 50% reduction in the level of sound that is transferred compared to before. That brings this deep dive build to a close. Thank you for joining me today, and I truly hope this video helps someone out there. Please like this video and subscribe. If you have found it deserving, please share with others and choose all, in the notifications, so you will be notified of new builds and music covers as they are released. I love reading all of your comments and suggestions, so do drop some in the comments below. Until next time then, I bid you farewell.